So this is the Z80 membership card computer designed by Lee Hart. I'll stick a link down below. He currently offers this as either the bare PCBs or as a kit, and I believe for the bare PCBs it costs about $20 for both of them. But you'll have probably, I don't know, maybe another $30 or $40 in parts depending upon your parts drawer. It's kind of an interesting little computer. It's a two-piece design. The first part here is the computer itself, and then this is just simply the interface panel here. Now, on this computer, I've actually modified this one, and this is his original version of the board. He's now updated this, and I believe that he updated it a lot because it's kind of a little... I'm going to be honest with you, the version I got, it's a little bit flaky. It's very, very, very dependent upon the actual parts that you use. I used some stuff that was a little bit different but functionally equivalent, and I guess it was just enough out of spec to where it just didn't quite work right. So I modified it in a couple ways. I did a couple little things. You can see some jump wires down here and this little header coming out for power. I don't use the serial interface with this board because it is RS-232, but it just never really seemed to work. But as far as it being a kind of a front panel interface and being able to punch in machine code and run machine code programs, it is a neat little project, very similar to, for example, the Kim Uno or something along those lines. But Lee Hart, he's done some pretty cool things. It's just his projects never quite seem to work out for me. I don't know why, but I always have problems building them. I always find bugs, and maybe that's because I'm using slightly different parts. But you know, a 10K resistor is a 10K resistor. NEC part is its equivalent on the TI is basically the same. So if I used a interchangeable part, you would think that it would work, but that just hasn't been the case with the two computer kits that I've had of his. But it is a pretty neat little computer. The front panel works for the most part. It is a little bit flaky. And this particular one, this chip here is a 74 LSO1. And first off, these are really hard to find. You can't find these. They don't make them anymore. They don't sell them anymore. The only place you're going to find them is on the surplus market. And my understanding, it is an open collector circuit. But the problem that I had with this is these things burn out. I don't know why, but they do. I don't know if it's just trying to sink too much current or what. But I've had problems. So I actually had to install a socket so that I can change these out as I go, and I ended up buying about 20 of these things just so that whenever one burns out, I've got another one to replace it, because it seems to be a fairly frequent problem. When I say fairly frequent, meaning that out of the probably 10 times that I've played with this, I've burned out 2 chips so far. So, and that was just doing the everyday normal stuff with the computer. So it is what it is, but it is kind of fun to play with. And there's some other people that have played with it as well. There's actually a hookup for a piezo speaker as well. There's one guy that actually played Daisy and a couple other things. But anyways, we're going to take a look at the chips on the board. On the computer board itself, obviously we start off with the Z80 processor up here in the top left corner. Next to that, we actually have, make sure I'm oriented correctly, a HC368 and a HC138, and we have a 74HC273 and a 74HC245. We have our ROM here, which this current version is the ZMC version 1.1. I think he's updated this a couple times since then. And then over here we have a 32K SRAM. So it has, I believe, the particular ROM that I'm using is a 64K ROM. I actually have the program in the upper memory so that whenever pin 14 is pulled high, by VCC, which a 27C256 would be. That particular pin is always pulled high. That way it basically sees the proper code in the right address space is all it does. It did have a 7805, but he actually calls for a L4941BV here, but it's kind of a, you can use either or, but one of them you have to put on the bottom side of the board in a different orientation, and then this one you have to put on the top side of the board in the normal orientation with tab down. So kind of weird, but okay, whatever. Now on the panel itself, he's got this LCD screen here, and that LCD screen is actually a pretty, I'm going to be honest with you, it's kind of an obscure part. There's only one place that you can get it. It's actually, let me see if I can try to find it for you. It's through some weird surplus parts store. I don't know where he got the idea to actually get it from there, but for whatever reason, they're the only people that sell it, and it's kind of well, it's not really expensive, but it's kind of a difficult part to source outside of that. I'm not seeing the. Oh wait, here we go. Let me see. Front panel. Yeah, it's a ROM LS-2074M2G. And the part source is from mpga.com, which I can't remember the actual name of the website, but it was kind of obscure. They actually put them on clearance not too long back, and I ended up buying, I think, like 15 or 20 of them, just simply because they are kind of a cool part, and I wouldn't mind using them in some other projects. But you're definitely going to have a hard time sourcing this particular LED display here. And it's, I think it's a 7-digit. Yeah, I think it's a 7-digit display, but it also has LEDs here. You got 1, 2, 3, 4, 5, 6, 7. So you actually got a total of, I guess, 14 different characters. Well, you know, little indicators. 7 of them being characters, and 7 of them just being LEDs. Now, after that, you've got a 74HC4040, a 74HC393. And a 74LS145. Now, that's possibly some of the problems that he had with this was some mix between CMOS and TTL, but you know, he mentions in here that you also can go ahead and use the 74 HC145, but the reason why I think he did this with LS was because it was supposed to be interacting with the LS01, which now he's actually updated this to use a 74HC05, which actually at one point I think he was using something completely different from that as well. So I think that this is about the 3rd or 4th revision of this front panel. To me, that pretty well indicates that he's got some issues that he's trying to work out. But for the most part, it works. After that, you've got a couple transistors, capacitors, you know, just passive stuff. You got some of these up here, and these are actually for the RS-232. You know, that way it does its thing. And he's got some pump charges in here to basically get the voltages right. On the other board, I forgot to mention, you also have your crystal here, and if I'm not mistaken, I believe that crystal is a 4 megahertz crystal. So it's yeah, it's a 4 megahertz resonator, crystal resonator, or ceramic resonator. So that's it as far as the board layout. Like I mentioned, I did mod this area right here so that I can just provide it with 5 volts via this header right here. And it does, you know, connect to the board through a set of headers here, as you can see. And of course, on this board, it's maybe hard to see, but I've just got the pin headers. The way he has it set up is you actually have to push the plastic piece down to the bottom, put it through, solder on the top side, and then you're able to, you know, close it in here. And I'll actually put this on so that you can see. Like I said, it's kind of a weird way that you have to do this. I've put this on like so. And for some reason that's not wanting to go down. There we go. Stuck on the wire. So once it's down, then multoid scan. You can take this, and that actually fits in there quite snugly. It just barely touches the top. You can see there's a little bit of flex there, but whenever you want to use it, you simply just break it out. You hook up your power through this cable here. And then at that point, of course, I've got a paper backing on the bottom side of the can so that it doesn't short out, but it is held off the can with that plastic from the header, so that should help. But then you're able to, you know, punch in your code. So it's kind of a neat design. As far as form factor, it's really cool because I don't think you're gonna find this much packed into such a small package with almost anything else. He's got another computer that he did based around the 6502, but you know, for fitting in an Altoid scan, that's pretty impressive. It's quite a bit of work, so I will give him credit to that. You know, it is a pretty neat way of doing the computer. I do want to try to find some of the red screen material to lay over the LED here so that, you know, it doesn't shine through. I've looked everywhere and I can't seem to find that stuff anywhere. If anybody knows where you can find that in like a sheet form, like, you know, maybe 8 inches by 8 inches, I'd love to have it because I've got so many projects that I use LEDs for that would come in super handy. However, for the life of me, I cannot find any of it, and I don't even know what it's really called. I've seen it before, but it's just impossible for me to find with my Google Ninja skills being very novice at best sometimes. So, but here in just a minute, we're going to go ahead and power this thing up and we're going to take a look at it. Okay, so I have this hooked up to my bench power supply, which is based around a modified AT power supply. But before we turn it on, I want to go over a couple things. First off, we'll go over the LEDs. So the LEDs up here, obviously it's a D1 through 7. For the lower LEDs here, this first half of this is the register indicator. Second one is memory. Third is modify. Fourth is output. Fifth is the monitor. Next is run. And then the last one here is, it says beep. So I'm assuming that's for the beeper that you can hook up to this. As far as the keys are concerned, it's laid out in kind of a standard ASCII, standard hex format. You've got 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, and F. Now, number 7, it acts as step, A acts as advance, 4 acts as go, 5 acts as in, 6 acts as out, B acts as back, 0 acts as register, F is shift, E is memory, and D is modify. Now if you hold down 0 and F at the same time, it does a hard reset. F and E does a soft reset. Okay, so that's pretty much it. Now also, this does have a built-in serial monitor. Like I said, I've never had the opportunity to use that because I could not get the serial interface to work. For the life of me, I just could not get it to work. So he's got a little manual here, and I'm going to try to go through it so that we can take a look at it. I'm trying to find, I guess this is it. We'll go ahead and turn this on. So I'm going to turn this on. As you can see, it says cold 0. So if we press E and then FF1, so E, F, F, F1. Well, that didn't work. Let's try to reset this. See, that's the problem that I get. Whenever I pressed those two, I ended up with a soft reset, and that should have been a hard reset. So let's try this one more time. So E, which should be here, and then it should be F, F, F1, and it is not working. Interesting. Well, let's try resetting it again. See, and it does this. See, it's kind of flaky. Now it's going to work. Okay. Well, let's see if we can get this thing working. Okay, so register worked. That showed us the stack pointer. We can advance through there and take a look at the registers. Okay. Alright, so currently we have the indicator for the monitor up. So let's see if we can examine memory. So I'm going to press E again, and then let's try another area of memory. Let's try 8, 0. No? Oh, I think I know what I'm doing. We actually have to press it kind of fast. There we go. Okay, so this is the ticker. Basically, the software has a counter, a built-in counter that basically ticks, and this is what it's displaying. It's just it ticking and going through. I believe it goes all the way to FF, and then after that it starts over. Now we're going to press A to advance, and it shows the contents, and then we can press B to back up and see the ticker again. Now as far as modifying memory, it says press E, the first examine the location you want to change. So let's go to 8000 in hex. So alright, so FF. And then we can press D, which should be here, and then the hex values that we want to add. So, and it automatically increments. So this isn't too different from my personal Z80 computer that I played with. So now we can go back through there and we can see we've changed it all to 0. With the computer that I built, it had a little panel that I attached to it that did something very similar to this. Kind of a neat concept. This is a little bit clunkier to use in my opinion, but it's pretty neat. Alright, so we're going to go ahead and examine an area of memory again. So, alright, so we're back here. and then we're going to press D to modify. C3 0080. Now if we go back, well, we gotta wait for it to stop. There we go. So if we go back, you can see that we have C3 0080. Now this is just a basically a jump routine. It basically will just continuously jump back to 8000. Now if we want to examine the register, we can press 0 and then 6 program counter, which that'll show you where the program counter's at. And we can press D 8. Well, that's not right. Hold on. Okay. D8000. Okay, now we can see the program counter is at 8000 hex. And now if we press 4, it will run the program. And it is sitting there continuously running. So now we're going to try to exit out of this. So we're supposed to hold F and press E, which does a soft reset. Very nice. Now he's got a couple other things in here. As you can see, he's got kind of a how-to manual on how to operate this thing. It's kind of hard to fit it all within the screen there, but it's pretty interesting. He's got, you know, quite a bit of documentation that he's done, and he's put a lot of work into this. I don't mean to take anything away from him, because he really has done a great job with documenting this and coming up with a kind of a complex little monitor that's both front panel and over the serial port. So I got to give it to him. It's actually a pretty neat little computer. It's just I've had lots of problems with it, and of course some of it may be user error. I'm never going to say that it's you know, all his fault and all mine. You know, I didn't choose the exact parts that he had, but I would expect it to have a certain tolerance. I know on my own G80 computer project, it had a fair bit of tolerance, and I know on the Z80 computer that I did with the front panel and the breakout hex keys and everything, it was kind of the same. It was pretty reliable. It had tolerances, and I didn't really have any problems. And if somebody wanted to recreate it, they could certainly do so. But it's kind of a neat little project. I just thought I would share it with everybody, because it's not something that you see every day. You know, you don't really see a full-on computer that is the size of a Altoid scan and will literally fit within it. So, you know, if you're looking at buying one, I think that he's got a lot of the problems ironed out these days. But it's enough to kind of get the feeling of a educational board from the 70s and 80s. A lot of those boards were not much more than this, and you can put in programs. You don't have a whole lot of I/O, although you can tie into, I believe it's these ports here, and get some I/O out of them. You'd have to do some decoding logic, and of course that's more than I really want to mess with, but you certainly could do it. I think there's actually somebody that implemented this into maybe a little RC robot car or something, so neat stuff. But anyhow, I want to thank you for watching the video. If you have any questions, feel free to post them in the comments section below. Check out the website, retrodepot.net. I'll put a link to Lee Hart's website below as well, so that if you're interested in this, you can check that out as well. He also has another computer project that he did, which is a 6502 membership badge, so to speak. It's kind of a little badge you can wear around, and it has LED display, which is basically the same one. And he's also done a 1802 RCA 1802 project as well. So he's got several things out there. He's a neat guy, into electric cars and things like that. So I'd highly suggest checking out his website. Aside from that, like I said, any questions, comments, or moans or groans, gripes, complaints, you know where to put them. And of course, if you want to go to my website and send me a nastygram through my email address. All right. So again, thanks for watching the video. Have a great day.